Hello and welcome back to the data videos part 3. We're going to look at quantitative data now. So we looked at categorical where the main piece is creating pie charts and bar charts. But that's only half of data analysis. The other half is quantitative analysis. All right, categorical analysis, when you have categories, they cannot be averaged. But when you actually have values that you can take an average of, height, weight, all right, then you need a different type of analysis versus categorical data like eye color, hair color, gender, ethnicity, all right? Those things, all right, fall into particular categories and are analyzed with pie charts and bar charts. Quantitative values, which we are now going to look at, I have the top 25 grossing movies from 2003, all right? The top 25 values, we analyze them using a histogram. So I have the top 25 movies. Once again, we go into graph, histogram, and creating quantitative graphs is even easier. Select gross in millions, the value, and then just simply hit compute. Then from this, all right, this is a histogram. And if you noticed also, if you go back into edit, you can change the bin width and such to try and get a better picture if you feel this one is too vague. Then you identify the shape. Look at the number of humps, and in this case there's one. We call that unimodal, one mode. All right, there's also bimodal and multimodal. So this is unimodal and skewed to the right. The direction the tail heads, all right, is the direction of the skew. All right, so this is unimodal, skewed to the right. Now I've also identified there is an outlier here. However, you cannot tell there's an outlier until you do the other type of quantitative graph, which is a box plot. Create a box plot, select the data set, and then make sure that this value is clicked. Now this is auto-clicked, dependent upon the particular settings of StatCrunch. So make sure this is clicked. Use fences to identify outliers. Then hit compute, and this identifies that there is one outlier. And that's it. There's only two graphs to all of quantitative graphing. The big part of quantitative graphing is then the analysis of these graphs. So the graphs are simple to make, but what they mean is usually what we're interested in. So from the histogram, you identify the shape. Unimodal, unimodal, right skewed with one outlier. Then based on that, you identify the number, you identify the center and spread. The center and spread, all right, breaks into multiple categories. The possible centers are the mean, median, and mode. The possible spreads are the IQR, standard deviation, and range. Each of those, each measure of center is paired with a particular measure of spread. Mean is always paired with standard deviation, median is always paired with IQR, and mode is always mode, or actually to be more specific, if you're ever picking the mode, you're usually picking modes, plural. The modes are paired with the range. In this case, because, all right, the graph is skewed to the right, we would pick the median and IQR since, all right, those measures are resistant to outliers. Now it's important to know that the way they are calculated is resistant to outliers. It doesn't mean outliers don't appear in the data, all right? There's clearly an outlier in this data, but we would still use the mean, the median, and the IQR to identify the information. Also notice if you hover over the box plot, it'll spit out all kinds of information. The quartiles, the upper limit, the lower limit, it's very, very helpful in that regard. All right, so down to the outlier calculation. So the outliers is most easily found by identifying by creating a box plot. However, the box plot is created by using what's known as the upper and lower fences. That's why we click that. The upper and lower fences are the quartiles Q1 and Q3 plus or minus 1.5 IQRs. All right, the IQR is the measure of spread, multiply it by 150% essentially, then add it and subtract it from the quartiles. This identifies the lower fence and the upper fence, where if you have values outside of these, then they are outliers. If these values fall within these, they are not outliers. Notice that in StatCrunch, it does not identify the fences, but it says upper limit and lower limit. That means the highest value within the fence and the lowest value within the fence. All right, so notice it says the lower limit is 102.5, when we actually see the lower fence is actually negative 46.85. So StatCrunch calculates those values, but it won't tell you what the fences are because, again, it actually refers to the data which is actually used. So we can clearly see we have one outlier at 400 million, both because it is outside this upper fence and it is visually displayed right here. All right, by hovering over it, it says, oh, it's the value in row 1, 400 million. All right, it identifies it on both the box plot and using this calculation, which is known as the outlier rule. So creating box plots is very, very helpful. What is also very helpful is creating what is known as side-by-side box plots. Side-by-side box plots are very, very helpful. So US and European women's heights. Which of course is on the last page I check. Okay, so we have the US and European women's heights. We're going to graph this with a box plot and control click them both in, use fences to identify outliers and compute. This creates what is known as side-by-side box plots. By far, this is one of the biggest uses of box plots because you compare the box plots next to each other. So looking at this, we can see, oh, that the medians are about the same, all right? And then compare the spreads. Notice European women, right? Their heights are slightly more spread out than US women, all right? We can see, right, that the range, all right, is a little bit wider. These are what are called the whiskers of a box plot. And we see the whiskers on the European women box plot are slightly longer than the whiskers on the US women box plot. Also, we see an outlier in the data. So when you compare and contrast, every time you compare and contrast, you should always be mentioning center and spread. And again, we can do it with specific data, all right? So notice the medians are approximately the same for US and European women's heights. However, the European women's heights are slightly more spread out than the US women's heights. All right, so again, it's just comparing center and spread, and then also the European women have a outlier at, I think it was about 200 centimeters. So mention the center, mention the spread. All right, they're about the same. They're a little bit wider here. Note any outliers. When you compare, very, very helpful with box plots to compare side by side because it puts them on the same scale. If you were to just create these box plots individually, it is not nearly as helpful. Because when you put them on the same plot, it looks like they're exactly the same. All right. But notice the scales of these are different, and this is just not helpful. Always compare box plots side by side. All right. Hopefully that is helpful, and I will see you in the next video.